Oh, I think you're muted.
The classic error in Zoom. Okay, so I'm Dave Corcoran. I run the Onshape product group, and I'm one of the co-founders of Onshape. To give a little background, I was also the executive vice president of R&D at SolidWorks and one of the original developers of SolidWorks, and I've been in the CAD industry for over 35 years. There we go. Okay. This presentation is about CAD cloud and disruption. And really, it's a little history of the CAD industry, of Onshape, why we made Onshape, and are people seeing the slides? Just to check.
Yep, looks great.
Okay, great. And where we are with Onshape today. So a quick history of CAD going way back. There's been three major MCAD, mechanical CAD disruptions, in my opinion, in sort of the history of mechanical CAD, and they all follow tech disruptions. Those tech disruptions were in the early 80s, in 81. The first tech disruption was technology coming from major organizations in aerospace and auto into the commercial space. And two of the first products, two of the most dominant products at that time were CATIA and CADS 4. They were two of the biggest 3D mechanical CAD products. CATIA is still one of the biggest mechanical CAD products today. They ran on mainframes and custom hardware. And one of the big tech disruptions that happened was the ability to display 3D graphics. They were very expensive. They cost $75,000 per user. At that time, that was a lot of money. A typical engineer, I graduated from college not long after that, and a typical engineer then made $25K coming out of school, or even $20K coming out of school. So the CAD system, the hardware and software for the CAD system cost more per year than 3 times more than the engineer cost. Because it was so expensive, the only companies that could really afford it were aerospace companies, automotive companies, and very heavy industry companies. So the commercial base was in the thousands of companies. It stayed that way for a while until Pro Engineer came along, which was introduced by PTC, which is also the company that owns Onshape. And they introduced a product called Pro Engineer. Pro Engineer introduced parametric modeling to the market, true parametric modeling. And that technology really made solid modeling usable by a lot more people. So while the math was there to do solid modeling before that, it was really that feature-based parametric paradigm that made it usable. But it also followed a general tech disruption, and that general tech disruption was Unix workstations disrupting the mainframe and mini computer market. And so PTC was the first product that ran on effectively any Unix workstation. It actually worked on some other things too, like DEC mini computers, but its main business was Unix workstations. As a result of that, both the pricing came down of the CAD system and the pricing came down of the workstations. So it came down to more like 20 to 30K per user per year. And that opened up to a much wider market that included still big companies, but a lot more companies, machine design companies, medical product companies, large scale consumer product companies and things like that. And the commercial base opened up to tens of thousands of customers. Less than 10 years later, SolidWorks was introduced. I was one of the original developers of SolidWorks. It also followed a tech disruption, and that tech disruption was PCs, Windows-based PCs, being able to handle 3D data. And the big thing there was that they became double precision memory double precision operating systems. And so that brought the price down from 20 to 30K to about 6K per user for the combination of hardware and software. And that again opened up the market to much smaller companies and even startups. Really 1 or 2 person companies could now afford to do 3D CAD, 3D parametric CAD, and that increased the commercial base up into the hundreds of thousands. So that was 1995 when that was introduced. Pretty soon, sort of by 2000, all of the products started to look like SolidWorks, meaning they were all primarily on Windows PCs. So here's a picture. These are just some fun pictures of the late 70s, what working on CAD looked like, to the mid 80s, to really any time between 1995 and today. This is SolidWorks on a Windows PC. I believe that we've started the fourth tech, or actually the fourth tech disruption has started. And like I said, these disruptions are independent of the CAD industry. And what is that disruption? That disruption is cloud-based distributed teams solutions, where people don't have to install anything, and they can access their data and they can use their system from anywhere at any time on any device. So there's zero IT, it's team-based, and anybody can access their data and their product at any time on any device. So here's just some products which have dominated their industries as a result of that paradigm shift. Slack, GitHub, Salesforce, Google Docs, Jira, Office 365, has pivoted to offer the things that Google Docs introduced, this team-based, cloud-based paradigm. So they adjusted to the change in the paradigm, and I think that was important for them to do, because Google Docs offered fundamental advantages that now Office 365 is starting to address. So what is a unified cloud solution? Well, Onshape was built from scratch to be like Google Docs or be like Salesforce, which means it's multi-tenant, cloud, SaaS-based product, full cloud-based architecture. The data and the CAD system live in one place on the cloud from the user's perspective. They actually live on lots of servers all over the world, but from the user's perspective, it's in the cloud. They don't really care where it is running. And they can access it whenever they want, from whatever device they want, and they can access it from whatever machine they want. So when we say device, that means you can do everything from a phone or a tablet or from any browser. The process is fully integrated. If you look at products like Salesforce, it's not just the sales information or the customer relationship information. It's also that it's fully integrated. You can communicate with other people in the process at any time you want. The same sort of thing with Jira. It's not just that it's cloud-based, but that you can communicate with people as you're moving along. People can see the single clear evolving source of truth. And in a lot of these products, for example, Google Docs, you can restore any version of your work that ever existed. And that's true in Onshape too. You can, if you create a document, you could work on it for 5 years. You can return to any point that ever existed. That's something you could never do if all of that was stored on your own computer. So one of the things that we found that was interesting is, users don't only collaborate with teammates, as sort of you saw in Allison's presentation, but they also collaborate with themselves a lot, where people will be looking at an assembly and looking at a part at the same time, and editing back and forth between two different devices. So one of the key things here is that when you want to do something disruptive, you really have to start from scratch. You really have to basically, and this is sort of the innovator's dilemma, right? Like a lot of people, a lot of companies have a tendency to say, well, we can take everything we already have and nudge it into this new paradigm. That doesn't really work. And I think, Steve Jobs was the poster child for that. Like, you know, there were certain things, a lot of the things about the iPhone are things that they decided not to do. They decided to not have a physical keyboard. They decided a lot of things about the iPhone that were different than what everybody else had done with a personal assistant type device before. You know, and I think that's the key, is that you have to really commit to the difference. One of the interesting things that we saw when we started Onshape is we found out through interviews that when we went to talk to engineers about what do you want from this new generation CAD system, they actually talked a lot less about CAD, and they talked a lot more about not having so much wasted time. This is a survey that was done in 2020, asking people, giving people a whole list of things that they said were the most important to improve. And interestingly, these are the top 5. And interestingly, the top 2 are being able to access the correct design data when you want it, and even being able to locate the correct design data. So this is interesting because this is all professionals. The next one was unproductive meetings. So you can imagine everybody just likes unproductive meetings. So you can see, like, actually getting access to the data and finding the data was the biggest problem. This even surprised us of professionals today in design and manufacturing. Why is that? It's because in traditional product development, CAD data is very, very siloed. That's something that Allison also talked about when she showed the picture of the wizard. You know, the CAD system is typically usable by a small number of people, and that data tends to stay with them until they throw it over the wall to the stakeholders. The stakeholders review, give them some feedback, and eventually it might reach a point where they throw it over to product manufacturing, and product manufacturing now gives feedback, but it's been a long time since the design team started. So as a result, you have this error-prone, non-collaborative process, which is very non-agile. And you know, if you go back in time, that's what the software development process used to be. If you're as old as me, if you've been around that long, you sort of know that in the 80s and 90s, the software development process was very much like this. It was very much a waterfall thing where you wrote specs first. You didn't write any code. People developed independently. They didn't see each other's work. They submitted to a central place. A team tried to build it, get all the bugs out of it, and then distributed it. Usually there were a lot of problems left in it. And, you know, and then everybody tried for another week to add stuff to the stuff they were doing. And it was a very, very formal, slow, siloed process. A lot of the manufacturing process is like that today. And one of the things that you see is that actually what a lot of you guys teach in universities about the best way to design things and design together and design as a team, and to think about the manufacturing aspects of things early in the design process and get feedback early in the design process. When your students get to the real world, they realize, you know, they can't work that way. Or their company that they joined doesn't work that way. And a lot of that is because the tools prevent it. And, one of Allison's slides that really hit home for me is, sort of reintroducing teamwork to the design process. It isn't something, it's been being taught that way for a long time. And in some sense, the teamwork was better before the CAD tools than after the CAD tools, because people did have to get sort of into the same room and talk about things and see prototypes as they were developing. So in some ways, although the CAD tools have been great, they're really more personal tools and less team-oriented tools. And that's the thing that Onshape is trying to change. So the goal here is that there is constant visibility. There's a user interface that's appropriate for the persona. Not everybody is a CAD expert. So stakeholders should have an easier, more intuitive user interface than the CAD developer, the CAD engineers. Still, because it's cloud, you can use permission-based access and you can make it extremely secure. In fact, more secure than it could possibly be if you're making copies and mailing them around in email or copying files. So, you know, and the internal stakeholders and the manufacturing process, the people on the shop floor, inventory specialists and all that sort of stuff can get involved right from the beginning and see the evolving design. So let's take a quick switch and jump into Onshape for academics. And first, you know, I'm going to look at 3 areas. Let's first look at academic research. There's a few very interesting things where Onshape offers opportunity for academic research. One is Onshape works like GitHub. You can sign up for free and you can use the product for free. Your cost for doing that is that all of your data has to be public data. So it's the same model as GitHub. Of course, all that public data is accessible to the public and under an MIT open source license. And with the right research opportunities, that public data can be used as input to various machine learning and AI research endeavors. So that data is basically effectively, because we remember every step that went into creating a model, it covers, you know, you basically have access to every step of creating those public models, and you can do machine learning or AI research on that, or on the model results themselves. There's also a public API, so you can access the data through the public API. We have something built into Onshape called FeatureScript. That is a language. It's an open source language that allows you to create custom features. Those features are first-class citizens. We also use FeatureScript to define all of the built-in features. You can see all of the source for all of those built-in features. So our extrude feature, our fillet feature, all of those features, you can see exactly how they're written in Onshape, and you know, you could fork it and modify it, or you can write your own feature. That feature is a full-class citizen. It's no different than our features. That's very, very different than all other CAD products, where usually you have a macro capability, but that macro capability is not a first-class feature citizen. And then we're developing a full integration with Jupyter Notebook to allow development in Python, and some of the things you saw in the breakouts and related to are using the Python interfaces. You saw even the Onshape countdown is driven by Python. So that's one aspect of academic, Onshape for academics. Another is for classrooms. Here we feel like there's things that we offer that just can't be matched by anybody else. Number one, you have no IT, and you have the requirement of, you don't have the requirement of having a CAD lab. Your students and your TAs and you can work on any device at any time. Everything IT related is handled by Onshape, including backups. In fact, you have a backup of every step that ever happened. You have analytics into activities. People can collaborate in the same way they collaborate with Google Docs. It's highly secure. It's based on our commercial enterprise product, which is used by some of the biggest companies in the world. So, you know, we have to have high security. That same security is available to universities. Onshape literally never crashes. You know, that's because of the architecture. Up in the cloud, servers are crashing all the time. But just like effectively Google Search and G Suite don't crash, what that means, they're crashing all the time up in the cloud too, from what I've read. But you know, what happens is, like us, they're storing data every step of the way. And when they get disconnected, they just pull in another server that's running and replace the one that crashed. And so from your perspective, it doesn't crash. And we're in the process of developing more and more classroom specific features in Onshape education products. Finally, for student projects and teams, it really is, you know, unparalleled. This ability to work collaboratively together is unmatched. And also we have the ability to branch and merge along the history of building the model. Like I said, you can go back to any state that ever existed. Every state is stored as an incremental microversion. That's why you can go back to any state, but you can also pick any one. You can name it as a special version, and you can branch off and create a parallel tree where what you're doing has no effect on the original branch. So very much like version control in software systems like GitHub or Git, you can branch, work independently, and then merge later. Of course, you have real-time analytics of team activity, and there's built-in tools to comment and chat and mark up and even assign tasks. So Onshape is growing. It grew over 300% in education last year and reached a 1 million user milestone in January 2021. Onshape's commercial enterprise also grew over 100% year over year. So we have twice as many Onshape commercial enterprise users as we did a year ago. And this chart is a chart of usage hours of all Onshape users, all categories: commercial, public plan, and education. And as you can see, we've grown in a healthy way ever since we started. But it's really starting to accelerate in these last couple complete quarters. So to summarize, we believe education, and I think you believe education is about training tomorrow's workforce and doing cutting edge research. And, we believe Onshape is the product that best represents what product design will be like in the future. It's happening today. We're growing very fast today, particularly in the education market. And we're looking forward to doing as much to help educators and to be part of moving the industry forward, moving the state of product design forward for education and for commercial business. So that is it. And it looks like I was pretty close to on time. So that's it. Thank you.
Great. Thank you so much, Dave. A really perfect way to wrap up the Digital Transformation and Education Summit. Onshape really poses all of these brand new opportunities for what digital transformation can be. Obviously, Onshape is from the computer-aided design space, but it poses these new opportunities for how it can integrate across this digital thread and be used by Industry 4.0 to bring new value in new ways, but also particularly for education. So thank you again to all of our presenters today, to Allison and Yuri and all of our panelists, and huge shout out to all of the students and the poster presentations. I think this was a smashing success. So thank you to everyone that helped put it together, from PTC education team. And I hope we'll be doing this again soon. So we're at the end of the summit, but we'll be sticking around here if anyone's interested in continuing the conversations. I've just turned back on the permissions so folks can unmute themselves and join in the conversation. I've also put a link in the chat here to our GitHub Pages site. So that's what we're hoping is a nice landing page with all the resources for getting started with PTC technologies, and some of the more cutting edge integrations that we've been developing and highlighting a bunch of the thought leadership going on around the world. You'll find our email there, so please reach out with any questions. We'd love to support your work, and we're always looking for the thought leaders that are pushing the boundaries of what's possible with digital transformation technologies. So that's it. I think I'll wrap up there, but again, I'll stick around if anyone is interested in chatting or learning some more. Thanks.